Hi everyone, welcome back to GridPro. Today we will explore one of GridPro's time-saving features, density-based split. This tool plays a crucial role in accelerating grid convergence in GridPro. Often the grid smoother takes a significant amount of time to converge, particularly in regions with high curvature, if those areas are not adequately represented by a sufficient number of blocks. The density-based split feature is especially useful in such cases, as it allows users to increase the number of blocks to represent the curvature while preserving the density distribution at specific locations. Traditional ways to split a block in GridPro. In GridPro, a block can typically be split in two ways. 1. Using the Insert option in the GL part. Press the I key and left-click on the edge where you want to split the block. Alternatively, right-click on the edge at the desired location and select Insert or Multi-Insert. 2. Using the Insert button under the Create section. This method provides another way to manually add inserts. Now let's take a look at how the density-based split can be used in different ways to split the blocks retaining the densities. We have a topology for the new Glen rocket, consisting of 5,878 number of blocks. Let's run GridPro's grid, Smoother G grid, and check the resulting grid. As you can see, the grid has a maximum skew of 0.81. While the grid is smooth across most areas, it struggles to capture the high curvature region of the elliptical domain. The cells near the high curvature have first cell spacing of 1.74, while the cells near the tip have first cell spacing of 0.57, which shows the cells near the curvature region is not converged yet. To improve this, let's first try to increase the cell density by twice in this high curvature region and check if we can achieve a smoother grid. Even after 2,000 sweeps, the grid in the frontal curvature region of domain is not smoothly captured. This issue arises due to an insufficient number of blocks representing the curvature. Applying the density-based split. To address this, we will group the corners of the edges that need to be split using the density-based split option. The current density of the edges being split is 88. With this feature, the existing block will be auto-divided based on the formula number of divisions equals current density divided by base density. For example, if we set the base density to 4, the number of divisions will be 88 divided by 4 equals 22, which means we will get 22 blocks with 21 inserts. If the chosen base density is not a multiple of the current density, GridPro will split the edge such that all the split blocks will have the same density, and additions of all the individual densities will be equal to the initial density of the block before splitting. After applying the split, the selected edge is divided into 22 equal sections, with 21 inserts added. By checking the density values, we can confirm that each section has a density of 4, ensuring that the overall density remains consistent with the original grid. This allows the high curvature region to be represented with a greater number of blocks. Additionally, the flags allow edge deletion and allow internal wrap can be used as necessary. Allow edge deletion flag can be enabled when there exists the wrap inside a wrap scenario in which the corners of the wrapped layer are free to move from inside to outside and outside to inside of the corners used for wrapping. While normal insert can create an additional inserts, the allow edge deletion flag automatically deletes the additional insert to retain the valid topology. The flag allow internal wrap comes in handy when the topology consists of a self-looping structure such that the topology sheet may intersect itself, creating a loop. The normal insert may not split such a structure, but enabling the allow internal wrap flag adds an insert and splits the self-intersecting loop. Now let's run Grid again and observe the updated mesh. After applying the density-based split, we can see that the high curvature region is now accurately captured with a smooth grid within 1,200 sweeps. Once a high-quality grid is achieved, the block count can be reduced if necessary by merging the blocks using the merge option. This process reduces the block count while maintaining the minimal necessary blocks in the grid. By using density-based split, we can achieve faster grid convergence in fewer sweeps, significantly improving efficiency in GridPro. We hope this video helps you optimize your workflow and reduce grid generation time. If you found this tutorial useful, don't forget to like, share, and subscribe for more GridPro tips.